Yeah, there we go. It got recorded. For those of you that know me, they know I tend to get fascinated with certain subjects, and today's topic is no exception. Before we started this, we were all in a little practice session chatting, and uh, Dan Albright was reminding me that we used to work together, which we very much did. Um, Back in what I refer to as my LSI days, and Dan was at Storage Tech. And, fast forward to today, I came, I went from LSI Logic to NetApp to IBM. But when I left NetApp, I decided there were two possible companies that I would like to work for. One of those companies was a company called CleverSafe. And CleverSafe at that point in time was like the gold standard of object storage. And it was new and it was foreign to a lot of people. They just did not understand this concept of object storage. Yet, object storage, even years ago, held a lot of promise. Well, the interesting thing was I checked into CleverSafe and there just weren't a lot of openings. And I went ahead and applied to IBM and got on to IBM. And 3 months after I got on at IBM bought CleverSafe. So it all came full circle. And for those of you who may not know, today you would know CleverSafe under its IBM name, Cloud Object Storage. So it's a fascinating world and it's a small world out there. And today we're joined by Russell Catalano and, as we mentioned, Dan Albright. And we're just going to chat about object storage. And for those of you that don't have a great understanding of it, um, open your mind and really listen because it is fascinating what can be done and what is being done with object storage. And with that, let me kick it off. And Russ, what is the difference for folks between, say, NAS, network attached storage, and object storage?
It's a great question, Roger. Real quick question. I'm sorry, but can the audience put questions in the chat? I don't know if Scott covered that.
They
If
absolutely can, and I'll keep an eye on the chat. So if we do get questions, we can go ahead and bring them up.
Okay, perfect. Thanks. Okay, again, thanks for having me. And just to address some of these questions, I too came from NetApp and have been working in the space for more time than I can remember. And the topic for object storage or the use case is very similar to that of NetApp, where we talk about unstructured data platforms. So traditionally, when you've heard about big data, data sprawl, data growth, all that big data, it's the difference is it's unstructured data versus structured data. So not to confuse the two. So unstructured data are the large amounts of data that, you look at emails, office files, images, things like that, that you would have in your home directories. That's unstructured data. Structured data would be more like databases, operating systems, where you traditionally would consider flash platforms for that. So NetApp and EMC Isilon traditionally were the unstructured data NAS appliances of choice. They were the gorillas in the space for umpteen years, and that was the only option you had. So a NAS appliance was the platform of choice to put your unstructured data on. Fast forward, there was a huge demand to address challenges associated with NAS appliances, how to back them up, how to mirror them, how to scale them, how to manage them, and a whole plethora of challenges. So object storage platforms were developed to address a lot of those challenges associated with NAS appliances. And that's where object storage came in to address those. And they did a great job. And it's not necessarily an appliance as much as it is a platform for object storage or for, we'll call it unstructured data. Because when you get into different terminology, it's truly an unstructured data platform where now you can choose between a NAS appliance or an object storage platform for your unstructured data.
Okay. And for all of you folks listening, I was informed just now that the Q&A does not seem to be functioning. So if you have important questions that you would like to ask in Slack, please reach out to Warren Wilson. In Slack, it may show up as at W Scott, W period Scott period Wilson. And we can kind of get those relayed on. So following up then, Russ, on what you just said, can you help us understand the difference between, say, an object and a file?
That's a really common question and you have to think of it as it's a different platform. So a storage platform doesn't change the file that's on it. So let's say, for instance, you have an image file, an MPG, an MP3 for audio file or JPEG, whatever, or a PowerPoint file. If I put that PowerPoint file on an object platform, it's an object. If I put that in a NAS appliance, it's a file. Some people look at that as they're different files. It could be misleading, but there is no difference between a file and an object. It's just the way the storage platform handles it. So if you had a PowerPoint file, an Excel file, again, if I put it in an object bucket or an S3 object platform, it's treated as an object. If I put it on a NAS appliance, it's treated as a file. But to the end user who's storing the file, it looks like the same file. So it's the platform that dictates whether it's a file or an object, not to be confused with there's something different about the file.
Now, is it safe to say that with an object, though, it can be like file on steroids in that I can add, as the storage person, I can add additional information to that file to make cataloging or data movement at a future point possible. And along with that question, you just said something that I know a lot of people have asked before, and that is, what do you mean by an object bucket?
Sure. So two-part question. Let me address the first half. So you brought about metadata. So traditionally, if you think of metadata on a file, you have modified date, creation date, file type. Though that's traditional file metadata, and you're very limited to the metadata that is associated with files. So fast forward with these new operating systems and new applications that look at file, and most people associate this granular, robust metadata with either images or music files. So if you think of looking at your iPhone, for example, and you look at an image file, nowadays with your image file, when you took a picture with your camera on your phone, you could actually see the camera settings, the GPS coordinates, all of that content, and you could have custom data. When you take a picture of your brother, your sister, it might tag that file with their personal name. All of that is object metadata, not to be confused with file metadata. And I'm oversimplifying it, but that is a huge differentiator between the way object platforms handle files. I'm sorry, object platforms handle file versus NAS platforms when the way they handle files is the metadata that's associated with the file. In an object platform, you have a lot more metadata. When you think about music files, for another examples, you no longer have limited metadata with file date, creation date, modified date. You could have album cover, artist. You could even have album cover image associated with the metadata. So the metadata associated with objects gives you a lot more granularity to categorize those files. And the other big differentiator leading into the second half of your question is for search purposes. If you think about limitations of a file system, you have all these folders that you have to sort and put your files in to organize them. Well, step away from file systems with folder structures and imagine just one big repository with metadata. And I use the analogy of your music library in iTunes, where you have, let's just use an example. If I have 1,000 songs in my library and I have all these different playlists, where a song could exist in different playlists because of the metadata, but it's all in one big bucket. In a file system, if I wanted a song to exist in multiple folders, like let's say an album or a type of music, disco, Donna Summer, or beats per minute, I'd have to have multiple copies of that file versus just putting it in a virtual playlist where that file could exist in multiple playlists. And the ability to sort and search based on metadata versus file lists, it offers you a granularity and a simplicity in search queries that you wouldn't necessarily have in a file or a NAS strategy versus object. And that huge repository where you put your files in, that's referred to as a bucket or a vault, depending on whose platform you're using. So that large bucket is where you write the data to, and then based on the metadata, you can search and query it. So whether it's on-prem or in the public cloud, or whether it's IBM's Cloud Object Storage or one of our competitors, it's either a bucket or a vault where you write the data to. And another analogy I use is back in the FTP days, where you wrote the data to an FTP site. You didn't necessarily have to give it a folder, you just wrote it to. So S3, which is the bucket, very similar to FTP.
Okay. Well, and you just you just touched on something that a lot of folks ask, and that is, what is S3? I mean, that people hear it all the time. Particularly they'll be talking about Amazon, and suddenly they'll say S3. And obviously, if you're familiar with object, you know it, but otherwise, it's just right over a lot of folks' heads. So, if you would, what is S3 for everybody?
Great segue. So thanks to Amazon and their vision 10 plus years ago, they developed a protocol called S3, not to be confused with their tier of storage and their offering in their public cloud. So S3 became the de facto protocol used to write to object platforms. 5 to 10 years ago, there were competing protocols that different platforms used. But today, I would venture to say that 90+% of the object workloads are standardizing around the S3 protocol. So when you think of NAS appliances, you would write to those NAS appliances using CIFS, NFS, SMB protocols into a NAS platform. So you have the NAS platform and you wrote to it via a protocol, and those protocols were developed by the operating system or the file system, and the standard ones that most people utilize are CIFS, NFS, SMB. Fast forward to object, we had to have a different protocol to use for object platforms, and you write to that bucket using the S3 protocol. Now, the S3 protocol stack, very similar to FTP. You've got the puts, the gets, the reads, the writes, and all the different switches and the fully qualified command line. So if you ever wanted to familiarize yourself with the S3 command line, instead of using an interface, you could do that via, you could familiarize yourself with the S3 protocol stack, which is very similar to FTP. But today, most applications that take advantage of the S3 platforms or object platforms use the S3 protocol stack within their application.
Okay. All right. That's actually super helpful. I hope folks got that. And again, you're doing a really good job of making this easy to follow up with you. You were talking about Amazon and creating this, and I have folks that, particularly if they have very little intersection with object, or they just don't realize it. And I really like your use of like your iPhone pictures and stuff, that here's this big bucket. But does object always need to be cloud-based, or can it be on-prem?
So historically, when you think of Amazon or the public cloud vendors, they were the first ones to introduce the object platforms. When you subscribe to storage in the public cloud, you're typically subscribing to an object repository. You swipe a credit card, you create a bucket, and you can start reading and writing and start writing data to it. Over the past 5 to 10 years, the demand for object storage has really ramped up because of the benefits of object storage over traditional NAS appliances, primarily the economics, then the scalability, the ease of use. So a lot of the challenges associated with scaling NAS environments or that strategy were addressed with object platforms. So now, when you start looking at the economics of an object platform on-prem seem to be a lot more compelling than subscribing to an OpEx strategy in the public cloud. So by no means are you limited to an object repository in the public cloud. You can subscribe to a public cloud repository with any of the public cloud vendors, IBM Cloud, Amazon, Google, AWS, Microsoft. You can subscribe to a bucket and you pay per gig per month. And competitive rates are like 2 cents, anywhere from 1 to 2 cents per gig per month. And it's an OpEx cost model. The competitive is that of an on-premise object platform that typically you would deploy over multiple sites so that you have site resilience. You've got a lot of resilience. You've got RAID capabilities built in, and the whole architecture on-prem offers you the feature functionality of an object platform, the scalability, the ease of use, and it's a CapEx model where you own the storage, you own the data. It's in your data center. And that's compelling for most organizations that have data centers. So you'd rather have your storage in your data center. So object platforms offer both on-prem usage solutions and public cloud subscription models as well.
Okay, great. Well, let me ask you one more question, and then I'll turn my attention to Dan. I don't want you to feel lonely, Dan. So, um, one of the things that fascinated me early on with Clever Safe was this, and you mentioned it again just a second ago. You talked about protection or RAID or that type of thing. And Clever Safe was the first time that a lot of folks started hearing this term erasure coding. But most folks don't have a clue what erasure coding is. Uh, can you help illuminate this?
Sure. In fact, I'm going to take two terms and try to describe them because they overlap a lot. So, two terms you hear with feature functionality of object storage are erasure coding and geodispersion. So, when you look at those two terms, when you look at a storage platform, think of RAID, for example, where I have a bunch of drives and I write the data across all the drives so that I can sustain the loss of certain drives. The ability to write the data across all those drives, most people use the term striping, or the ability to write the data across multiple drives is erasure coding. I'm doing nothing more than taking that data, taking a file that I'm writing to a bunch of disks, writing it across multiple disks so that if one disk fails, I don't lose a subset of the file. I can recover. Let's just do basic RAID 5. If I had 3 drives and I wrote a file across all 3 drives in a directory, I could lose any one of the drives and still recover the entire file. I'm never losing 1/3 of the file. So the ability to write it across all the drives is erasure coding. Now, those 3 drives, this is a limitation of a NAS appliance. Those 3 drives have to exist in an appliance in one data center in a rack. If if I were to be able to take those 3 drives or a couple hundred drives and spread them over multiple sites, you are now geodispersing your drives. So think of it as, I was with a client once and they coined the term a wide area RAID. And I loved it because the concept of it was, if you think of a NAS, it's just a bunch of drives in a RAID appliance. Well, you know what? Let's take those drives and spread them over multiple sites. Now, if I write that file to all the drives over multiple sites, not only can I lose a bunch of drives, but I set up that RAID so that I can sustain the loss of any one site and still recover all my data from the remaining sites. Whether it's 2 sites, 3 sites, 4 sites, whatever the case may be, you could sustain the loss of multiple or one or more sites depending on that RAID. So erasure coding is the ability to write to multiple drives, take a file, chop it up, and write it to multiple files. Geodispersion is the ability to take a bunch of drives and expand the beyond an appliance and expand it beyond multiple sites so that you now have site resilience. Because historically, all you had was with traditional NAS appliances, you had to mirror it. And that just doesn't scale these days with large data sets. So geodispersion is a lot more economical and a lot more efficient than mirroring data between 2 sites.
Okay. Well, and you and I had a colleague that, we both worked with in the past at Clever Safe, and I believe it was he who told me at one point that one of the largest Clever Safe, i.e., cloud object storage clients, was basically achieving about a 16 nines configuration because of the sheer size and geodispersion and the methodology that's used. So, pretty impressive. But Dan, let's jump to you. I think you're the right guy for this. Who are our top competitors in the object storage space out there? Who should we be aware of as we're talking to potential clients?
Yeah, that's a great question because I will say that from a competitor standpoint, it has changed drastically over the last 2, 3 years with the advent of really real strong commercial use for storage in the cloud. So I would say our top competitor, our number one competitor, is any cloud vendor. Typically, we run into AWS commonly, certainly Azure, sometimes Google. And so, and what's driving that is that many, if not most customers, have a cloud first initiative. And so, by virtue of that, we are constantly going into opportunities with that strategic initiative in front of us at our clients, and then having the dialogue of what that really means for them and what it means to them really from a cost standpoint. You know, as Russell had pointed out, there's OPEX and CAPEX considerations. But once you look at the cost of cloud compared to an on-prem COS implementation, more times than not, we are more cost effective over a span of 3 years or more. So it is something that anytime you identify opportunity, and there's vast opportunities, for COS and any object storage, um, you're going to run into consideration for cloud. Now I'll pivot to on-prem competitors. On-prem competitors, what you'll commonly find is Dell ECS. You'll find Hitachi, HCP, which has been in the market quite some time as well, and then HP Scality. There's others out there, but from a on-prem standpoint, those are the competitors we typically run into.
Okay, and I would assume, although I know the danger in assuming, that if we did get into a competitive situation, we could potentially reach out to you for some assistance and suggestions.
Oh, absolutely. Yeah. The team that Russell and I are part of, we're all very well versed. We got the scars and wounds from many battles. I have to say we win them most of the time, and it is important, is to try to get away from the commodity aspect, meaning that price per terabyte, though many times you're forced into it when considering object storage. There's so many other components associated with that, and especially it comes down to workload and other opportunities we'll talk about in a little bit.
Okay. Well, as long as we're talking about this, Dan, let me stick with you for a minute and ask, because this is a question that comes up fairly frequently, and that is how does the how does object storage performance basically compare to, say, that of NAS storage?
Yeah, that question comes up. It is one where NAS as a platform has its place, as does object storage. Um, NAS best used for, I'll say, performant type workloads, where there's a decent amount of I/O required in the performance that demands performance in order to, use NAS cost effectively. But within NAS, what we find many times is that up to 80% of the data stored on NAS has not been touched in a year. Okay, so why is that significant? Well, that means that from a performance standpoint, there's very little performance demand for that data that's sitting there for such a long time. That is the data that actually belongs on object storage. Object storage performance is all about throughput, and typically the workloads that are best used for object storage have a uh, characterization where it is written once and rarely used after that. I mean, just think about your personal data that you use on your laptop or PC or phones. Photos. You'll take a snapshot of a photo. You'll share it on text. You share it via email, whatever. Uh, Put it on Nix. You know, there's a lot of applications out there, but the use of that photo dwindles quickly over time. But you want to keep it. It's a personal asset. Same thing for commercial businesses, right? They have files and that have not been used. They're very important. It could have been uh, you know, a report to C-level. It could be images for marketing. It could be scans. It could be, you name it, depending on type of business. And it was a very important asset and used frequently in its initial creation. But once time dwindles, there's a new version of that or a different item that is displacing it. Yet it's a very important asset to draw on, and therefore they want to keep it for the long term. That's where object storage is used. And that dynamic, all that does, it builds demand for more storage. They don't want to get rid of the asset. So the next one that came along, now that data is going to be dwindling as well. And it just perpetuates itself in terms of demanding more capacity, yet it's infrequently used. Unstructured data, it belongs on object storage. It's great news for us selling object storage because there is a constant demand for upgrades. I call object storage, from a storage seller standpoint, the gift that keeps on giving. And that is so true. We have customers that invested into COS, within the last 18 months, and they have reordered upgrades, capacity upgrades, twice since that initial um, purchase. And so it is something that, and especially you think about it from an AI standpoint, that's all the buzz, right? AI. Well, where does that data come from? What does AI use for data? It uses a data lake, so to speak. And what hosts that data lake? It's object storage. So it is, again, an incredible platform, supports multiple workloads, and based on the usage, that'll have a certain performance demand that is very friendly to an S3 protocol and to object storage.
Okay. Well, that's fantastic. And actually love your example of the photographs. You know, for any of you listening to this, in North America, we just celebrated the 4th of July. And my wife was mentioning the other day, I really like that picture, little video that I took of a little cardboard dog, and you light it by its tail, and it basically kind of poops out a snake. And our little grandkids loved that thing. They thought it was fantastic. I haven't been able to find that photo since I took it years ago. And all of a sudden on Facebook, it popped up and said, "Hey, here's a memory from a bunch of years ago."
Right.
And it was that picture. So you're dead on. Oh, see, that gives me goosebumps. You're dead on. So much of that data, you don't want to lose it, but you sure don't need to be paying for a high performance storage configuration. Now, let
Yeah,
me ask
and
another.
on that point, Roger,
Yeah.
is that the cost of NAS. NAS per terabyte is 2 to 3 times, sometimes 5 times more expensive object storage. So it's
Oh,
not
I did
only
not
the
know that.
performance aspect, but it is putting the data and the asset in a more cost-effective storage platform, and that's really the comparison. In fact, that's one of our best offerings. When we talk about what kind of workloads, there certainly there's long-term backup. We talk to archive. We're talking to, but we also partner with a couple of very excellent technology partners. Comprise is one that I'll highlight here. Addressing that 80% of data is sitting on NAS that belongs in object storage, it has the capability to scan that NAS and through that scan, understand the age of that data, and then based on the policy set by the client, move that data. It's not a migration, it's a move of the actual data, leaving behind a symbolic link, okay, on the NAS. So the NAS still owns that data, but it is transferred to a more cost-effective storage, being object storage. And what does that do? Then the backflush, it stops the proliferation of NAS and allows NAS to be more efficient in its primary mission. So when we talk about opportunity for COS and for object storage, that is, in my opinion, the top opportunity. If your client has NAS, you automatically have an object storage opportunity.
Okay. Well, we're beginning to run out of time here, but I've got two kind of questions that I think sort of go together, and either of you guys, whoever is, would want to jump on this. One is that, we know that there's a lot of scaling that's involved with object, that it can become really, really enormous. And, as you mentioned earlier, the gift that keeps giving. Um, so people frequently ask, one, do I have to back it up? Because when you start getting petabytes of something, backing it up becomes interesting. And sort of the follow on to that is it hard to manage? So I'll leave that with the two of you. I don't know who might want to take that.
I'll respond to that. So when you use the term backup, it pigeonholes you into that traditional strategy of copying data to tape or copying data to another archive tier. That strategy just doesn't scale anymore. You start introducing different types of strategy into backup with deduplication, incremental step forever, and you try to dress that up to make it more efficient, but there's only so much you could dress it up. So you have to start looking at your backup or your strategy into other means of data protection. So do you have to protect the data? Absolutely. Do I have to back it up in that traditional manner? No. So what we do is we take RAID, we take geodispersion, we check all those data protection boxes that you need to protect your data, to make it bulletproof, to protect it so that you don't run a risk of losing it. So erasure coding, geodispersion, worm, a second copy, all of these features help you with your data protection strategy, even though you're not backing it up to tape. If you wanted to make a copy on tape, you can do that. It's just that unfortunately, the way this unstructured data is scaling these days, it just doesn't meet Windows. You can't meet Windows. Otherwise, it's just not efficient anymore to back it up in that traditional manner. So you have to look at other strategies to protect that data. And, just to add on to that, when you say backup, IBM is very uniquely positioned in the object storage space because we, unlike other organizations that offer object solutions, they're either going to be in the public cloud or on-prem with one product on-prem. IBM offers a plethora, multiple object storage solutions. We offer public cloud solutions. We offer high performance on-prem solutions with scale. We offer, we own Ceph now. We have cloud object storage from the CleverSafe acquisition. Every object storage workload is becoming more and more demanding and scaling out. So IBM has made a huge investment in object storage so that we can meet all workload demands with one of our different products, because we look at it as a partnership. with your adoption of S3 object workloads versus just trying to sell you one product and you have to then tailor your workload into that one product versus, listen, you have a workload, we're going to provide you with multiple products to meet whatever workload demands you have. And that's what makes IBM very unique in this space, that we have multiple products that, yes, they do overlap, but we have the full spectrum of performance demanding products to meet whatever workload demands you have.
Fantastic. Well, gentlemen, we are out of time. Um, and this, I have, like I said at the beginning, I've always been fascinated with object storage. I'm really glad we've got experts like yourself that are well versed with a lot of experience. And it's definitely nice. This very last things that you were talking about, the fact that we can deal with an on-prem, in cloud with multiple products, that we're not pigeonholed, uh, is a big win. And I would encourage folks that are listening to this, as Dan and Russell mentioned earlier, we've got a great team. And if you find yourself in need, don't hesitate to reach out to us. But with that, I should probably turn things back over to Scott before he just kicks us off because we're over time. So, Scott, I will hand it back to you.
Thank you, Roger. Thanks, Russell. Thanks, Dan. Appreciate you guys joining and sharing all this information with everybody. So yeah, I'll end the recording here as soon as we're done and post that up to our YouTube channel. And if anybody has any questions, wants to follow up, you're always welcome to email me at w.scott.wilson@ibm.com. And again, thank you for spending part of your day with us today, and look forward to talking to you next month at our next Tech Talk. Thank you.
You're very welcome. Hope this was helpful.
Everyone.
Take care, everyone.